do you see my screen?
Yep, looks good.
Okay. Hello, everyone, to another live coding session, which today live coding session is a little bit different. We are exploring some of the lesson in module 302, which was published around Monday. And we are happy to present some of the things that we were working, some tools, utilities. I hope it works. I know you guys would enjoy to see the people who call themselves teacher, instructor, fail in front of you. We were students, and we always love to see that our teacher struggle, and I don't know if it was some kind of giving some feel of satisfaction. So today we are going to do that, and we are trying to create a project from scratch. Although, as you may see in these SLTs, creating and updating and maintaining a Plutus project, the whole topic around that would be on lesson 302.2. But because we wanted to kind of have a lesson which is more inclusive. So it's not just about theory and talking about and concept and abstract stuff, but kind of hands-on experience and codes and practice and this quote-unquote struggle. Therefore, we are kind of combining all these lessons. Although we will have in next upcoming Tuesday, I think in next 2 weeks as well, we will have a particular session about these specific topics as well. And sure, we will have more depth in those topics. But without further ado, let's focus on this first student learning target, which is about how can I plan and implement my Plutus contract. So you guys always heard about this smart contract, all these bringing ideas and implementation into blockchain technology, namely Cardano, and of course with the language Plutus smart contract. But before starting to go deep down into these code and what's going on with it, we need to have a kind of a little bit different mindset compared to other blockchains. So we have different blockchains already, and maybe you may know about that. For example, Ethereum. Ethereum is the account-based blockchain, and the account-based blockchain, things are different there. I don't want to go deeper. You can search about that, sure. But the idea with account-based, main idea is once you do something on blockchain, the whole blockchain will get affected and change and behave according to that. And we call this change a state. And a state of transaction, a state of things, and a state of a behavior of a dApp or anything you are building. But in UTXO world or UTXO-based blockchain, well, the famous one is Bitcoin, but later we have other blockchain which is based on UTXO, namely Bitcoin Cash. But Cardano and Ergo, and there are some other blockchain coming with this concept of eUTXO, which is extended UTXO, which they deploy a smart contract on top of this UTXO. And the mindset and the design for this smart contract in Cardano and UTXO-based blockchain is quite different. And the difference is the state that I was talking about account-based, at there it is global. So again, if you made a transaction, things change. Like whole things change, whole blockchain change. And all of them must know that you've done this transaction. But in UTXO, no, the state is local. And local means we have some inputs. We call them UTXO. They have imagine they are bucks of data. And inside it can have a token, namely ADA or any other token, NFT, and of course, datum, which is a data attached to this box, to a box of data. And once this box changes, whether it's combined or merged with other box to become a bigger box, or it will break down or divide into a smaller box, everything will happen with that transaction. So the state will be inside that. The other boxes in other part of the blockchain will not get affected. So how do we create a smart contract which works with this mindset, and it will work with other boxes? And there are some key concepts and key considerations for this planning. And first and foremost would be determinism. There is an UTXO-based blockchain, we call them secure and account-based, because they don't have side effect, aka estate, global estate. So in that box I was talking about, if you create a transaction to change or to do something about that box of values, maybe the data would be the value or the token, whatever, the result of that transaction will always be one thing. It cannot be two things, it cannot be three things, and always input and always output must be clear, and it will be clear. So once you create this mindset, you need to create that a smart contract based on that. So you have to know what are your inputs and how you want to handle them. And you have to know what your output be and how you handle them. Therefore, the smart contract in Cardano start with something like for example, you guys, you have this access to this repository, which consists of all the smart contract we were talking about throughout our course. But I made this lockbox contract, but it doesn't matter other contract. For example, always succeed contract. So we see that there is this function, but it maybe doesn't tell you that much or like what's going on. So let's look at to this lockbox, or even actually facet. So in facet, you see that we have this treasury validator, which is a function, and you may know function always gets an input and always produce an output. I mean, doing something to those inputs and produce output. And the input here are 4 input, facet parameters, which are the contract parameters, datum, redeemer, script context, which is again that state of the local state of transaction, and Boolean. So you see the result of this function, it doesn't matter what this smart contract is always Boolean. It is whether true or false. There is nothing between, like the transaction will be successful or not. So if you have an idea about bringing something to Cardano, you need to think where inside that plan, that business logic you have is absolutely binary, is absolutely white and black, and absolutely 0 and 1. And if it is not, you need to break down that idea or that part you want to bring. Normally, we need to think of that financial part of the idea we have into sections or parts which are absolutely binary, which is, again, deterministic. So you have to know what would happen. You have to know what are the input. You have to know what are the output. And then based on that, you can continue planning, which the next consideration would be the input parameters. Like what are your function parameters? And of course, designing the logic based on this idea of binary, this idea of transaction will be successful or not. And of course, estate management. And we will talk about this in short time when we start creating a smart contract with help of Akish, I think. I hope he's here. Yeah, Akash, yeah. And of course, error handling and security. And error handling, there are some things I should say about that, like error handling when, and error handling in development and in once you want to launch your product, it will be a little bit different. Because error handling, if you do not error handling, of course, you don't know what's going on. But if you leave this error handling like intact, like the error handling, you've done it in your development phase, like you don't want to change it, it will actually cost you because each errors is costly. Like handling things inside Plutus, a smart contract, means there will be a Plutus size, like there is a bytes somewhere, therefore the size will increase. And the size, if its size increase, transaction fee will increase. Even if the size doesn't increase, maybe the memory execution or memory usage or CPU execution will increase. So we will talk about it and about, of course, security. And here I hope I wasn't able to add Gimbal App utility, no problem. If not, we can talk about it later and in the next session. That I want to show what you should be aware of. Like, of course, you may know that, for example, this is a smart contract. Like, okay, this is the ACAN or Plutus, doesn't matter. Your smart contract looks like this. This is a CBOR hex. Everything is a number, but these numbers are coming from a binary, and that binary was encoded in CBOR hex. And that binary, you need to be aware of what information will be visible. So I want to show you that actually you cannot put your like very secret word or whatever into your parameter, into a contract parameter, which will be hard-coded inside your Plutus contract. And it is a vulnerability. It is I cannot call it even weakness, but it is a vulnerability that you will leave like your secret code or secret salt or whatever here. And it doesn't matter, it is like an integer or byte string or whatever. So we will explore that, and there are other security concerns, and there are some places I would like to show you that, for example, in Cardano certification working group, we are working on a list of vulnerability, which I hope I can show you. By the time we will, I don't think it will be ready at least this week, maybe in some other weeks. But yeah, there are some lists that we are working for, some vulnerability and weaknesses, and some of them are famous, like multiple satisfaction, some are not, like UTXO hijacking or data hijacking, or like UTXO DOS or DDoS attack, all these things. But yeah, there are these things that you need to be aware of once you want to plan your stuff. And of course, about the multisig, like if you want to secure your smart contract, you want to import or insert some pubkey hash, so like it should be signed by someone several people have. So yeah, I was giving this example of token vesting contract. It should be like, it was a series of contract, but to be honest, I decided to not give the code because it was too much for this lesson, for all of these things. But I hope maybe we can do that. Although I wrote this token investing contract, proof of concept. It is in my repository. But anyway, so let's try this thing. Let's see these concepts, this key consideration in action. And yesterday we talked with Akash about a project he was building, and the idea was someone comes and let's say he's a landowner and he wants to mint a token in order to represent that land and on-chain. So if someone have this NFT or token, it means that that person have the ownership of that land. So the design he was working was someone mint that token, and that token will be sent to his wallet. And then if someone wants to buy that token, the token will be sent from the wallet of that person to the buyer. But there was this issue that if the buyer wants to buy that, again, that seller or that landowner or previous landowner must sign that transaction, because that token rests or exists in his wallet. So we propose him to have a smart contract in middle, which namely we call the escrow contract. And that contract can hold that token. And once the person comes and buy that token, that contract can validate the situation, like paying all these parties and so on. And then the buyer will get his token and that NFT, and that seller will get his the amount he was offering or he was selling. And now there is no need for waiting for that person to sign a transaction, and again that person must pay a fee or whatever. So let's start to starting to building that a smart contract. So I need you, Akash, to help me to tell me actually what information you would need from the seller and of course the buyer. And I should say that there is a minting contract here, but for sake of time, we don't want to focus on that minting contract. And we are assuming that that minting contract will create that box of data I was talking about perfectly. So we are assuming our inputs are handled by minting contract, and it is okay, it is good, and there is no problem. Although it should be taken into consideration that that contract, that minting contract, should have all sort of validation in order to create that box and send that to the escrow contract. But I don't know, maybe if you guys want, I don't know, if you want, we can start working on minting contract. But since you guys have a minting contract already, we can look to the escrow contract. So what do you think? Well, let me put this, start in this. Yes.
And just in terms of design, you can address minting validation logic at any time, right? We might have it already and want to plug it in later. Yeah. Or you might say, hey, I'm going to test this contract with a dummy token for now. And later, I'm going to create a Plutus validator that gives me control over when those tokens would be minted.
Exactly. Since we have this local state and local transaction, everything's just local. If we have several processes, and like there is this user coming to your application, and in your application there are several steps that this user must proceed through them. And again, this is a deterministic process that you have to define this process. Like if there is this if else, like if there is several options, again, you have to determine what would be option. And if there is something other than an option, you need to handle that. So let's assume that you have this process. In each of these steps, or each of these station, or each of these level of progress, you have to have a smart contract. And maybe, for example, there is this minting contract. Maybe there is a spending contract, which we are working on right now, like escrow. Maybe a staking contract, maybe certified contract, maybe anything. So the thing is, these contracts have to have some connection with each other. but they do not aware of each other. That's the thing. In the Ethereum, if you write a contract, the contract is an active contract. The contract itself can execute something, can generate something, can, it's like a general code. But in Cardano, it is a passive contract. So someone somehow must trigger this contract. How do you want to trigger a contract? In order to bring a contract to life or to bring it to an action, you need to bring one of its input into a transaction. Once you bring that input, once you bring that UTXO from that contract, now the contract is active. So remember, contracts in Cardano are passive. Someone outside must trigger them. Someone outside must make them into action, like make them live, or pressing a button on them or something. And how do you bring that contract into the game, into this process? Once you bring an input from that spending contract, if it is a spending, if it is minting, well, you need to have this minting, like this minting. Do we have, for example, this minting switches? So once you do that, you trigger. We have these different contracts. So for a spending, you need to bring an input. For minting, you need to have this one. And for a staking, you need to have at least something in reward address. I hope later, I don't know when, but later we will have a module or a course talking about these staking contracts and certifying and how to actually withdraw and how can actually create some business logic around that. But yeah, contracts are passive in Cardano. And with minting contract, which, for example, that in our case, owner or that landowner create, once you create that transaction, once you create that UTXO, and you will send that UTXO alongside that token to the contract, to the escrow contract, and in next step, the buyer wants to buy that and bring that UTXO, that input from the escrow contract to the transaction. Now we can say the escrow contract is live and now do validation. So that's the thing. The inputs, you need to have some sort of control. But you might say, how can I be sure? How can I be sure my inputs are correct? Like, what if someone create, because we cannot control, right? Everyone can send whatever they want in Cardano. Even if the address is wrong, if the address doesn't exist, you can send it. There is no problem. And actually, you cannot that much distinguish between a wallet address or a smart contract address. So like, all of them look similar. Even native script, again, its addresses look similar. So the thing is, we are going to explore that. So it's not that much easy. I can say, like, yeah, you should do this, do that. So okay, let's start with this escrow contract. And let me start with validator. Validator.hs, right? If it is ACAN, well, if it is Plutus, doesn't matter. But first, let me check the chat. I mean, if there is a question or something. By the way, does anyone have any question, please open your mic. No, because if I'm not seeing any hands, but
I saw the big bash script, and that's just that's just showing some of the transaction logic and things in there that you're just
and these bash script are for the facet mini project mainly, but there are some other bash script which we can, for example, balance. Like, it just accept an address and it gives you the balance of that. So I think it would be module module 204. And once you reach that, and all these lessons, you need to clone this repository, PBL 2023 Plutus template, and then working through this facet mini project, understanding what's going on with the code, and of course with this bash script.
Nice.
Why we need the bash script? We can't query the particular address within the smart contract only.
Well, if you want to do these things with CLI, so like let's say that you do not have a front end, you do not have mesh library, you do not have any code with this bash script, still you can interact with your contract. Still you can lock some amount, unlock some amount, mint something, burn something. So these bash scripts are they do exist for working with Cardano CLI. And in order to use Cardano CLI, you have to have a version of the blockchain, or not the version, another. What they call that? Like you need to have the Cardano node. So you need to have this blockchain running. You need to connect to the blockchain directly and interact with it. This thing can happen. Actually, this thing can be possible for actual real project as well. Like you don't need to have this browser wallet or this or that actually, or all this. There were this project. We didn't have all these libraries back then, and people were creating this transaction and sending that transaction to backend, and in backend these tools were submitting, these tools were querying the blockchain, these tool was checking what's going on and all this stuff that we are doing with the front-end library. But I see James. Do you want to?
I unmuted, but Roberto has a hand up too.
Yeah, Roberto, go ahead. What do you
Hey,
think?
Mix. I was wondering, so is a bash sort of a complementary way to do that, what we were talking about of sort of triggering inputs? Is that a way to like effectively or maybe automate in a way that communication with other contracts? Like you said, nothing happens by itself, it needs to be triggered. So are bash scripts a way of through Cardano CLI to figure out what inputs out and trigger out transactions and trigger transactions?
Yeah. So for example, in Mint PBL NFT, which you guys do it in front end, like you just connect your wallet to that front end and simply you just mint it. But here we can do it with bash script as well. Like simply these two. And what would the triggering of, like, okay, we have this minting and we are specifying that, hey, there is this mint. This is the trigger one. For minting contract, this is the switch. And if you have this switch, you have to have other switch as well, like policy ID, and of course this, if the contract was deployed on blockchain, so it is not a file now, it is a UTXO, like the contract is attached to a UTXO in that box of data I was talking about, which holds token data. It is possible to add a contract code as well, a CBOR code. So you don't need to hold that file. But anyway, if you have that, which we call it ref UTXO, reference UTXO, you have to have all these as well. And it is a way of triggering, and it is a way of testing as well. So if you have knowledge of front end and a back end, and of course a smart contract, all these things, sure, you can write your code and start testing that code with your front end utilities. If it is a mesh library, Lucid, or other libs, or whatever, doesn't matter. But if you want to do it maybe quickly, and if you want to learn what's going on in deeper level, well, we would suggest to use Cardano CLI and Cardano node, and sync into that. Then you will understand what's going on. But as you said, in order to create this chain of reaction or chain of action based on the contract, yeah, we have to have, for example, this minting bash script. Then if it was succeed or it was successful, another bash script should start. Like at the end of this bash script, we will call another bash script, and then so on and so on and so forth. So it is possible to.
So basically, at the behind every wallet running this script, right, to create the wallet address and all these stuffs and doing the transaction, right?
Yeah, all of them. Yeah. But I should say that if you bring wallet, you have to bring PubKey hash, and you have to think of this multi-signature scenario. And multi-sig scenario are not that much synchronized scenario. Like not everyone will be ready at the same time. Not everyone, like for example, here we have this signing, right? You have this Cardano CLI transaction signing. And here we have one signing key. But if there is this process, or if there is this logic you are implementing for your whatever security, or for your estate management, or the logic or determinism, you need to be aware of that the signing is not synchronized that much. It's not something that happened at once. And I should say that once you want to use some APIs, for example, Block Frost, you have to take into consideration that there are some delays, like maybe 1 second or 2 seconds for submission, all these things. And of course, if it is not the multisig, if it is just one UTXO was signed here and so on, you have to again put this consideration that that UTXO must be submitted, must be verified. And, like for example, if in your wallet, if you create a transaction, you see that like in, for example, in Eternal, you see that there are some things around that transaction, like it is loud, like it was not confirmed enough, or it is like medium, like several nodes or several node verified this. Why it is not okay for, I don't know why it is not loading. Okay. Anyway, so for example, for being secure, it would be good idea to wait at least 3 blocks. And in Cardano, each block will be produced in each 20 seconds. So 1 minute. So if you want to consider putting this 1 minute delay of submission of UTXO, and you want to be sure that at least 3 blocks or at least 3 nodes was confirmed that this transaction was okay, although it's very unlikely that if a transaction goes through the first one, like the first block or first node, it would be unsuccessful or something bad happen. But for keeping safe, I don't know, maybe there will be some attack vector or attack surface in future. But for keeping safe, that 1 minute, like 3 block, 20 seconds. If you wait for that, you need to kind of wait, like put in some, for example, if it is your bash script, sleep for 60 seconds. So we can be sure this UTXO was changed, submitted, that block, that box of data was changed, and we are sure that that change is permanent. Now we can move forward to the next bash script, or next transaction, or next triggering of this smart contract, or maybe minting.
Piotr has a hand.
Yeah, Piotr. First of all, hello, my friend. How are you?
Hey, I'm good.
Welcome back.
Just a quick question. Do you know of any front-end interface where you can test your smart contract without writing the
No, actually, I was thinking about it. I was thinking about it, and I started actually before, the last summer of 2022, before I joined Equival. I was working on personal project. I wanted to actually publish it, and publish, no, saying out loud and working together about it. And it was called Plutus dashboard. And the idea was you just paste your Seaborg code into an input, into a box, and then you would be able to generate or create all sorts of datums or redeemers, which you guys know, the datums and redeemers are just JSON objects. We can see, for example, in here, lockbox datum, it's just a JSON. It's just a JSON object. So you could create this and interact with your contract, and all sort of error, if it would happen, it would print out. But I just joined to other project and I didn't pursue that project. But it would be great if someone pick it up, like even the name Plutus dashboard, and it wouldn't be just Plutus, any code. If it is a compiled. By the way, I've just noticed that why A can always succeed is actually bigger than the Plutus one. It's interesting. Anyway, so if you just paste this, or uploading this to that place, you could test it. And actually, that's it, guys. If you want to create this platform, that's it. Have an input which accept this JSON file or .plutus, or this is again the JSON object, but this is the important one. Reading this Seaborg hex, but it would be important to validate this one. Maybe it is version 1, 2, and we are near to talk about Plutus version 3 actually, maybe after the Cardano summit. But anyway, then just creating datums, which is like a JSON object, and redeemers, which is like, for example, this guy, a JSON object, and interact with that Seaborg. We have all sorts of libraries, but something with nice GUI, I haven't seen it. Maybe there are. If there are, I would love to test it out.
That it's such a good question, Piotr. And just that I wanted to mention to everybody, right? Like, these bash scripts are not necessarily the end of the story, right? We write them so that we can test the contracts we're writing. And although it's possible to build a server where you then run your bash scripts, there's better options than that. And so I want to get back to Piotr's question in just a second, but we think about our goal is to place applications in front of people who can actually use them, right? And that's usually going to involve designing some kind of UX UI. And so we have this need to translate into Mesh or Lucid or some other library that helps us run all that off-chain code, the transaction building. And what I'm really excited just to report to everybody from the developer side, as Gimbal Labs has started to take on some bigger projects, some of which you guys have heard about, some of which we can't wait to talk about more, we're able to separate the concerns of some people writing the smart contracts in Plutus, who can then hand it off to people who build front ends. And it turns out that the bash scripts are a really nice tool for that. They provide the documentation that the front end developer needs to understand how the system works, and then they can read through it and they can implement that in the library of their choosing. It's a really good process, and I hope that people can get some firsthand experience with that. We're going to build that direction. Now, with that said, it would be really nice if we could just take the bash script and not do all the translation into some front-end library, kind of like Piotr is suggesting. And I know I talked to Abdel Karim about this from Mesh months ago, and he's really excited. Like he came to me one day, he goes, okay, here's the idea, right? Just drop your Cardano CLI commands into the front end and then you can use it, right? So that's an idea that other people have. I know that he's really focused on upgrading some even lower level tools for building the off-chain code. But that's an idea that's on the mind of the mesh team. And for anybody who's interested in exploring that, that's definitely something we should follow up on.
Great, thank you, James. But I see, Piotr, your hand is still raised. Do you have an arm? Okay.
No, I'm sorry.
You could keep it as right, but it would get tired. Yeah. By the way, guys, Piotr, he was one of my first great teachers. So I owe many things I learned. I owe to him, and of course to James and Adrian and to other people, Abdul Karim, and of course Janti. So I'm really grateful of him. So yeah, I'm really proud to be in Kimba Labs and showing. Although I don't call this teaching. I don't call myself teacher or something, but I feel proud to be here among my dear teachers. So yeah, thank you. Let's move on. So the function you are seeing is the first step of a smart contract. And actually, this is a full-fledged smart contract. It works, and we call this always succeed a smart contract, because everything, if you put any input into that, if you put anything inside that, and once this smart contract raised out of the dead and now it's alive and wants to devour all this UTXO, well, he can't. Why? Because it's true. Just he can say, "Oh, you're free to go." So it's just a very cute little nice smart contract, which if you put anything inside this smart contract, which I'm using this word inside, but actually in blockchain technical point of view, it is not correct, but maybe we can talk about that later. But let's assume if you put this input, this box of values, which holds at least ADA. Like if you guys know that if you want to mint or send a token, any token besides ADA, it has to carry some amount of ADA, and it is depend of how much that token. Like if it is billions of token, then you need to have like bigger ADA. Like you have to lock into that. So there are this ADA carrier, which actually you need to consider in your business, but that's kind of an advanced topic. So yeah, this is the first one, but we don't want to do that, right? We want to have some logic into this thing. But before starting to do this, but first, look at it. This is a deterministic thing, right? This validator will validate one transaction or UTXO, and it will produce whether true or false. It is possible to spend that transaction or not. So in case of our escrow, if a buyer comes, it must be determined that this buyer can buy this token or not. That's all. There is nothing between, there is nothing above, there is no third option. There is always this. And maybe in some cases, you don't like this very deterministic and you want these side effects, like for example, creating some random numbers or creating some sort of cryptographic scheme around it. But it is not possible with this smart contract. Although there are some things that you can bring it into this logic, which might be considered side effect. For example, fees, because fees are kind of again deterministic, but we cannot know that much that beforehand what would be the fee. But again, we can know, but it would be in the times of transaction. So if the transaction doesn't happen, we don't know that all that fee. But anyway, that is again another topic we can talk about later. But now we have this function, and now we need to create and we need to talk about what would be the input. So let me define these first parameters. And these contract parameters are, again, deterministic. Why is that? Because it will be hard-coded inside the smart contract, and we cannot change it. It will give us extra layer of security, but as I mentioned before, you should not put anything sensitive. In plain text, if you can hash it out or encode it, I mean, not encode it, at least you have to encrypt it. And the difference between encryption and the encoding is, encoding normally means that you will change or you will shift nature of a string or digit or data to something else, but it is easy to just convert it or bring back to its original shape or form or a nature. But encryption, it's doing the same thing. It will change that data, that things, to something else. But in order to reverse it back, you have to provide some sort of password, some sort of verification. Like you can do that, you can decrypt it. And we have these hashing functions, which means it is one way. Like if you convert that to a hash, it is not possible to bring it back. So it's like the whole idea around hashing function, which we have different hashing algorithm and hashing tables. Right, the famous are SHA-256, 512. But we have this Blake 32 as well, which is actually faster. If you want to use it in your smart contract, I really recommend to use Blake 32 instead of SHA. But anyway, we have this one. So if you can use this cryptography, whether it is hashing or no, but actually let me show you some of these libraries to you guys. So we have this. If you can run your documents, all these things locally, great. But if not, I personally use this link, which is well, sorry, it should be pasted. Yep. So I'm going to paste this link as well in the chat. This is just the latest changes of, I mean, you can, of course, go with different branches here. Here is the main, but this is the documentation for all the code off-chain, on-chain we are using. And if we, for example, we want to see what cryptographic stuff option we have, we can do this Control-S, then like SHA, you can see that I just search it, and we can, and I should, okay, why SHA 256 on the line. Yeah, this one. So maybe one day we will talk about this documentation, but this is the original place that we can select. Plutus TX built-in internal. And we have this Blake 2B256. So this was added, not recently, but it was added, like it wasn't available in Plutus version 1. Yeah, this, as far as I know, I think it was added after Valentine hard fork, because after Valentine hard fork, these guys were added. Like the Valentine hard fork was adding different cryptographic to Plutus. So these are the things that you can use in your, of course, as your smart contract, if you are interested in some interoperability between blockchains like Ethereum or Cardano. These function comes handy. But for hashing, we can use this. So yeah, if you want to go with contract parameter, just be careful. So let's define this contract parameter and see what should be inside it. I'm going to use this. This is the type name, which we see that Akash escrow params, but this would be the type constructor. It will create this Akash escrow params. So it doesn't have to necessarily be this. It can be like something, like doesn't matter. So, but of course, the first letter must be this something, like it has to be capital. But anyway, let's go with this thing that if you are into Haskell, sure, you can go learn about it. But if you don't want to spend your time about Haskell, you want to spend your time about Aiken or Plutus or Helios or all this language, Ocean or whatever. So you don't need to just think about this Haskell stuff. So anyway, let's define this type. And inside this contract parameter, I'm going to put several other steps, but I'm going to ask a cache as well. But one thing I'm going to be sure that it would be here. And what would be, if you guys remember, I said that we have to create this set of a smart contract in different process. So when user proceed, we can be sure that these contract kind of have a connection. Here we can put that connection. So inside this contract parameter, we can say that, okay, currency symbol of, what was that? I mean, let's call that land minter. Okay. And then, of course, the type would be currency symbol. So byte symbol, and this should be current. What's going on? Currency. Okay. I don't know what is current. Okay, current. See. I think I'm, losing my mind somehow. So sorry for this inconvenience. Anyway, so we want to be sure if a UTXO comes to this contract, it must have a token. And if you guys know, the token consists of two parts: currency symbol and token name. Currency symbol would be same, but I'm not sure the token name will be same as well. Maybe token name would be the land of the, like that some ID belongs to the land. So I'm going to ask to Akash that once that landowner mints that token, what would be the token name? Is it constant or no? Always changes. Akash, can you hear me?
Yeah, it will be vary by person to person.
Okay, but is there any logic behind it? Like, do you have any like off-chain will handle it, or no? It should be something that like it should be absolutely open. Like we don't know what would be the token name, or no, we know at least.
No, sir, we will not able to find out what will the token name.
Okay, so we don't know, but still we have to handle it somehow. Okay, so let's see that how we can handle. So for now, let's leave this contract parameter as it is. If there are something that we want to hard code that, we can just add it here. But for now, nothing. Let's now define the datum. And datum is a data was attached to the UTXO, which will come to the this escrow contract. And datum is something that we can, by the way, we should add some stuff to it as well. I'm going to copy that from Lightbox here. Doesn't matter type. So for example, this one, we have to be like lifted. I don't want to go to people like, what is this? It relates to something about has template Haskell, and you have to like, there are some stuff you don't need to worry about. Just add this thing, and that's all. And of course, we should have some imports at top and some language extension as well, but let's not worry. And of course, sure, we have to, I mean, let's do this one at least because it's necessary. So module, it would be cache escrow and validator where this one, okay? So for the datum, I'm going to ask again, cache, what would be the name? But one thing I can put here, I can say the land ID. And let's imagine the land ID would be the token name of that token, that NFT, which represent that land on chain. So combination of this land ID, which is token name, with this currency symbol will create that token. So we can know that what's going on. Okay, what would be the other datum? What would be the other data or a smart contract needs in order to verify this transaction? But what transaction exactly we are talking about? Here we have, I mean, we are now focusing on one transaction only. And the transaction would be someone comes and buy this token, which means unlocking a UTXO, like in putting that UTXO, which was sent by seller to the contract and change it, like taking the token out of it and pay its price. So I can again guess that each token might have different price and it might determine by the seller or by the project. So we can add another data here, which the buyer must pay, call it price. And it would be integer. Integer. But what other data we need, Akash? Do you know what other data we should put here so our contract will validate? And maybe you can look to the front end code and see what are the validation you are putting in place in that transaction building. Like if the buyer wants to buy, are you considering some percentage, like a fee you want to get, or no, you want to just like provide this service as it is without charging?
So we will provide the service without charge, and of course, we will require the receiving address of of that user, right? So
Yeah,
can we take
exactly.
within that datum?
So we can say seller address, and here we will put it here. Okay, what else? Fee? Do you want to charge fee?
No,
No. Okay, no fee.
not for it.
So what other information do you think we might need from the seller? You know, by the way, I should mention that because this is again maybe that a little security. Always use address. Do not use pubkey hash. Like here, you can go with another something like a seller pubkey hash, and of course for pubkey hash, and of course for the sake of sending an amount, the ADA, pubkey hash would be enough. But Cardano is a staking blockchain. So the staking part of that, which the address actually consists of two parts, the payment pubkey hash and a staking pubkey hash. So if you do this pubkey hash, it means the payment, and you are not handling that staking. There are projects, I mean, at least I know two of them. One of them lost around $400,000 worth of ADA because they didn't just handle this staking part. So please always handle address. It might be a little bit expensive in terms of handling because there are these two different parts of this address. We might look at it here, but it works because it is secure. Another key consideration we were discussing. So, okay, but let's go with this. But if there is Akash, if there is other information, if you want to put in here, please tell me. If not, let's move forward with this information. Then maybe we can add later to it. So we have our datum, and this datum means that a UTXO, an ADA, which that token in that minting contract was minted.
Excuse me, sir.
Sure, go ahead.
Yeah. Why we are taking the seller address? Because seller is a escrow, of course, because all the NFT will lie within the escrow
Well,
wallet
the
itself.
thing is, that buyer bought this NFT, right? Let's say that that buyer bought this NFT for 500 ADA. That 500 ADA should be paid to whom? To seller, right? To the person who mints this land.
Yes, got it.
So the person who mints the land, the person who triggered that minting contract, we call that person seller. We can call it, but if you want, we can call it something else. So because a smart contract cannot know about what happened before this UTXO came to this address. It doesn't know, but we have to tell him somehow. We have to tell him that this UTXO was sent by this guy, that this UTXO was built, and inside that there is a token, and this token belongs to this guy. We have to tell this a smart contract. As I said, the smart contract works in local state. They do not have any awareness of anything outside the transaction they are working or they are verifying. So we are bringing this outside information, aka a state. This is a state. We can consider this as a state, a condition, a situation, something that happened, and we want to store it as a series of data, aka JSON object, and tell it to this smart contract escrow that, hey, I know you don't know what happened, but I'm going to tell you. I'm going to tell you. If one way would be the datum. Another way would be the redeemer, which we call it action. Because not all the things we want to use as a redeemer would be just redeeming something. Maybe it would be just triggering an action. Therefore, I'm going to use action. And of course, a script context. An script context would be important once we want to talk about time. And where is this? Yeah, here. So the smart contract wants to work in time. And of course, there are other things in a script context. But one of the most important things about this context, again, this state, like what is the blockchain? Like this blockchain is like the time of this blockchain or this transaction is in future, in past, whatever. We have to tell. So another way of telling our smart contract, what is the situation, what is the state, is a script context, but it is a limited one. We can see actually here, inside this documentation, script context, and you can see that it just have several. You can set the type constructor, or if we talk about in JavaScript language method. So Plutus, yeah, version this one. So, or a script context, which we have a script purpose, which say that, or a smart contract is what exactly? Like is it minting? Is it staking? Is it spending, whatever. And of course, we have this one, script TX info, the transaction information. And if we look at, that's all. The only thing our smart contract gets in a script context out of that transaction to know what's going on, like the outside of how, what's going on, what are the stars, the mountains, well, how am I, existent? And all these philosophical questions these smart contracts suddenly asking, it just as answered by these small function, we can call them, or whatever you call that. So we have to tell him some other stuff. So the datum tells that, like seller address. And of course, we are going to now work on the action as well. So again, let me use some of the already written stuff regards to datum for lifting stuff, but I think in types I have that. Yep. And let me add this one as well. This is equality instance. If we want to have some equality comparison or something we want to check, like there is this checking, like if this datum comes, or if this seller address or this price comes, like we want to compare, we want to do some arithmetic operation about them. We have to hard code that kind of, maybe we call it equilibrium, like this equality, into the Plutus core, into the smart contract. I don't know about the ACAN, like do we need to do that in ACAN or PolyTX? Maybe. I don't know about that. But in Haskell, in PolyTX, we have to do it. If there are some comparison about your data, about your datum, or even about your redeemer, you need to create this. So, and we have these three, let's say, I mean, it is not parameter, but let's call it parameter. So A, B, C, and I should add this one as A, B prime and C prime, and sure, let's put this guy here. Yeah, we can go with and. Yep, yeah. Use AI in your VS Code for, making your life easier. Yep, this should be true. And that. If you guys remember, there's this JSON stuff as we talk, this JSON object. This guy is going to kind of create that, like it will create that JSON inside the Plutus code. So inside the Plutus core, once you give that datum, this JSON object to the transaction, your smart contract must recognize it. Must recognize, like, okay, what is this? This is how you talk with your smart contract. So in order your smart contract understand your datum, you understand the data you attach to that UTXO, you have to create this JSON as well. How this guy will create. So if I put this, for example, here 0, like this index, if we assume this is the datum, the constructor here would be 0. So if I put, for example, here, whatever, like 102, here, this will be 102. So by this constructor, or by this kind of make is data index, your smart contract can recognize, oh, this is the guy, and then it will look to inside it. And of course, each of these again will get some constructor based on the data type they have, and so we can go with 0, 1, doesn't matter. So yeah, we have this, but I see Piot's hands. What do you think, Piotr?
Yeah, quick question.
Sure.
The place where you check for equality of the datums, I should say, the below on line 17 to 21.
Yeah.
Is this supposed to check for the type of the datum or the values as well?
The values, not just the values, but this index as well. Like for example, you might create same datum. Like if there is this UTXO as an input or as output that have a datum, and that datum maybe have same index or another index, like this number, like this thing, this here. But we want to make sure the whole object, not only just field, but you sure we might need the field, but the whole object also same. Like also it is like exactly this is. In order to do that, we have to create this one. So this instance not only check for the values of, like, for example, token name, price, and seller address, and checking that, like, if we want to check the seller address is equal with some other address, but it checks the datum, like the whole object is equal to another JSON object. Maybe that JSON object would be in a redeemer or some other things.
Okay, thank you.
Yeah, you're welcome. And again, I don't know this is necessary in ACAN or Plutus or something else. Maybe there is, but yeah, for now, I mean, let's assume there is. So, okay, let's go for the action for redeemer. I think for the action right now, we don't have that much of an action. So we can just go with one action. And the action would be buy, right? Like buy land. So this would be the action. But if there are other action, sure, we can go with other action, like sell land. Maybe there is some other logic we want to implement in our smart contract for selling land. Another action for would be like retrieve land. Like the person doesn't like to sell it anymore for some whatever reason. That's an option. Like the person, this seller, send that UTXO like 5 and say, hey, I want this land. I'm going to sell this land for 500 ADA, and that's token inside it. But I just changed my mind for whatever reason. I want to increase the price or decrease it, or I want to just take back my land. I don't want to sell it. We have to handle that, right? So, for example, we have to have something like update land, so the person can come and change this price, or now even retrieve, or maybe if you want, you can create a backdoor to yourself, and that's the thing. If you want to create backdoor, here's the place, guys. What would be the backdoor? A cache action. And how do we do that? Well, in parameter, we are going to add a cache key hash as well. We can add address, but since it is a backdoor, let's keep it, as secret as possible. Although it is not that much secret, everything, it's a smart contract. We are going to publish everything will be visible. But anyway, so.
And hey, Mix, just watching time. We're at about 10 minutes left. So if you want to.
So yeah, so these will be our actions, and we have this CTX. So let's create some logic based on that. Let's say go with buy land, okay? So now we want to go, sorry, I should put this in case. Because we have several actions, we want to have this conditional, like if based on the trigger, based on this action, what would happen? So we have this UTXO as a trigger, but we have this redeemer as a trigger as well. And if we have several or multiple trigger, we can create that. So let's create, like, for example, in case of redeemer and the datum, although the datum would be similar, like we don't have the different datum, or datum is same. So we don't need that. But if you have several or multiple datum based on the logic, based on that that determinism I was talking about, that you want, that we have 3 different datum, which means 3 different UTXO, and all of them comes to this smart contract. And based on this action and datum, we have to that this smart contract should behave differently. So maybe there is this ready-made datum and some other things. You can create this case and condition. And by doing that, you will determine that if this happens, this other process or logic must happen. And if none of them happen, it should return error. So let's do this. But because we have this, again, we have several ready-mares, but one datum, let's go with just one ready-mare. The case will change. So another part I was talking about error handling. One of the functions we want to error handle, at least inside the development phase, would be this trace if else. And it will accept a string as a error message and a function which must be a Boolean. So, for example, about this one, let's see that let's talk about this payment. So let me apply this one, but let me write this error first so you can see what's going on. So, but by the way, I should this is wrong. First, I should put this byland, and then under this condition, this must happen. And sure, there will be other, for example, cell land, and maybe something. Let's go for true. If it is update, sorry, it is update land, other logic. Let's go for now for false, for whatever reason. And then, of course, for that backdoor, which might you need, we can call it like debugging action or debugger action or whatever. And here, just we need to sign this transaction. So Akash needs to sign this transaction, and he can do whatever he wants. That's all. So, we have some function about that, but let me put this one like true as well, and then I'm going to put this error like seller must pay. Okay, so this is the error. If the buyer doesn't sell or doesn't pay this price to the to this address, then we will get some error. So how do we do that? Well,
That's trace if false right there, right?
trace if false or trace if, I forgot this function. If false, yeah, I think, yeah.
Yeah.
Let me, yeah, exactly. Trace if false. This is trace. We have another function called trace error, which just print an error, but we have this trace if false. Yeah, sorry. So let's just where is this? It was here, and then let's go for that function, and we call it like is seller paid? Okay, that function, and it will accept this seller address and the price. Seller address and price. But we have to have this access to this data. Somehow we have to get that data. Like, how do we get it? So there are some function I think I wrote here or no, that we can get its datum out of it. I'm going to write that because we don't have we have 5 minutes about that. But let's assume that we will destructure this datum and we will get access to this values or these parameters, and then we will put this one here. And then here I'm going to write this function, and it will accept an address, an integer, and return Boolean. So again, a deterministic. A seller will get paid in full or not. There is nothing in between. And in seller paid, we have this ADDR as a parameter and AMT as an amount. And we say that here. And we will look to it, like we will try to find that output which goes to the seller address. So how do we do that? Well, let me write this one out of my memory. Find, and it would be something like TX. We have a TX. We can't check that, but we can get TX out value, and we have to have a TX info resolved I, and then value of, you can't just simply don't care about this.
Well, this is not a part we want to rush through. I think it would be really good to show where these definitions are as well in the docs as you piece together this. This is such an important part of really starting to understand building out this logic and what the Plutus libraries provide.
Sure. Let me just finish this one token name, and then it should be equal to amount. So,
and can we pick up here next week? Maybe we can start from saying, okay, we have a partially working validator here. And then next Thursday, the goal is now to build a project around this so that we can actually compile this thing.
Sure. Yeah. Why not?
Because this is really good, that the pattern here, can you scroll back to the left? Of just starting out as you build out your logic, you see how like cell land and Akash action are always true. That's a really nice pattern that allows you to build out your validator piece by piece. That could be a really nice spot for us to pick up. Of course, this would always fail because update land currently defaults to false. So this would be an always fails. Well, that path would always fail. That's really cool.
Yeah, it is just a placeholder. Like we have, if we do not want to put that, sure, but if you have installed Haskell, there is Haskell linter, there is extension, Haskell server, forgot the name, HSL or something. It will just complain that there is this error or whatever. So you can't just put it as a placeholder, but yeah, slowly we can just move forward to create this smart contract. But that the idea is we were looking to this key consideration one by one. Like we were deterministic. We were sure that what would be this input. Like we were sure that this is the input of that UTX. So land price, seller address. And we have to make sure in that minting level or stage or step, this is handled. So the output of that stage, which will be input of this stage, this escrow will be deterministic. We know what's going on. unsure about input parameters. We just define that what would be the input. For example, the datum would be this, the parameter or contract parameter would be this, the action which will trigger different behavior of the smart contract would be this. So this is the input parameter. And designing the logic, well, based on the information what we got, we were designing this logic. So if it is the buy land, we were just making sure the seller get paid. And sure, we can design other logic, but at the high level or top level, you need to have this action in your mind. If not, you can add, no problem, but you need to have that. And the next level was state management. We didn't touch that much. We are going to touch it, but state management would be the datum of this guy. So in that minting process, we were creating this datum in order to tell this smart contract, to this the next step, to this escrow, what was happened, like what happened in that state. So this datum actually is our state. So by datum, we will manage this state between this step, between these passive contracts, or they are not as smart that much. They are not dumb, but not that much. And error handling. We just saw that, yeah, we will have several functions like trace if false, or trace error, or other function, in order to know what's going on. And not just that. So simply we can just remove it. It doesn't have to be here. Like we must remember that this thing at the end of the day asks and true or false. So it doesn't have to be there forever, but for error handling, for the process, for understanding the process, it is necessary. And I should add this one at the end of this case. What if there is another case? Like, all these.
Next, we should really honor time, though. Okay, we've gone over this. This is a great spot for us to pick up, but I want to really be sure that we've covered a ton today, and I'm sure people will have questions too. So be sure to share questions in the Discord. And let's talk about ways to make sure that we have time for Q&A at the end. But everybody, thank you for joining us in this experiment. I can't believe how much we covered. Amazing. And thank you, Mix.
Thank you, everyone. And I'm sorry for, like we didn't have the time for Q&A, but yeah, let's continue this discussion in our chat. I'm going to push this code as it is into PBL 2023 Plutus template. So you can check it out. You can see the code, and we will continue with this code. Of course, it doesn't compile. There are some errors in regards to it. Don't worry, but we will make it happen together. And thank you for your time. And yeah, let's continue. Let's continue our adventure.
Incredible. Thank you, teacher. And Akash, thank you for the use case. It's incredible, and it really gives us a way to illustrate this stuff. I'm excited to keep diving into this.
Yep,
hey,
thank you.
Yeah, till next time, everybody. See you soon.
Take care. Thank you. Bye.
Bye.
Cheers.
Thank you. Bye-bye.